Good morning. The science of presenting science. So, why this one? Why any of them is really what I'm starting to wonder. But when the sciences are presented, it's almost absolutely necessary that you understand what the audience can understand. This is the haircut. This is the grooming. This is the big diploma in a frame behind you. So I've got to use dosimetry, which is a very specific nuclear science. It is a nuclear and biological science. It is those two massive domains of science that try to put answers together, that try to pose the questions correctly to get the answers. So, first off, I've already lost most of the audience. But since you paid for the lecture series, thanks. So, the nuances of dosimetry. And this is the biggest issue around a nuclear event, because that is what defines the impact to all living organisms within the contaminated areas. So, first, it behooves you to know the contaminated areas. And once you know them, you have to know how to deal with them. This comes back to people waving a dosimeter around, a Geiger counter, any type of radiation detector. Each one of them has very specific rules for it to be used in dosimetry. This is something another video is about: ISO standards, international standards, consistent use of the sciences and the engineering to do things properly, to do things safely. These are big organizational considerations. This isn't what folks perceive it as. These are long, plodding processes involving humans building our civilization, for whatever you think that is. So, getting back to dosimetry, this is a challenge with any dose readings, is understanding what it means. The reason is that table of isotopes, not elements, isotopes. The 100 and some odd elements we have, there are 1,000 known isotopes, a few dozen off of each element. This is a world of ultra high purity materials that makes life today possible. It's what lets 7 billion people live on this planet. It is a major player of many in that is technology and science and our application of sciences. Because science is just knowledge. It's a collective knowledge we've built on and improved. It is a living body of knowledge, and everyone is a piece of it. Every person. It's amazing. Just incredibly amazing to understand, to begin to understand, and have the faith that it will help us understand, eh? So back to dosimetry. So here's the question I'm not going to answer, but here's the question that people that don't understand dosimetry, that wave a Geiger counter pointlessly around in the air and either make fun of it or make light of it. Now, that instrument's telling you something. If it's working properly, even if it's not working properly, it's probably telling you it's not working properly because you know how to use this thing and what it should be doing, to expect. And if it alarms, and then you walk away and come back and it alarms again, the damn thing's probably working. So, what does that mean? It means you have a meter capable of detecting high energy particles. That's as much as you know, unless you've had about 6 years of some pretty intense education to understand all the pieces involved here. You're going to struggle. You can be made incredulous, let's say, at what the media shows and presents and how they present it, because you know that 5-minute bullshit from some thunderballs person is just not true. It's not enough of the story. The shallow presentations of nuclear is good when all the source material comes from the nuclear industry, the salesman, the sales material they do share with us. So this is a tough conversation about a global industry. It's how the world works, the real world works. So that dosimetry, that dosimeter, that Geiger counter, mine specifically uses an energy compensation calibration specifically for cesium 135. I'd have to go back and look again because I don't use that. I only look at the counts from the detector, not what is called an estimated dosage. A very estimated dosage. So here's the question to the health physicists that won't come into these conversations because it's going to take hours to bring everybody up to speed, or else it's just another moonland we can argue about in some circles. So the question is, ladies and gentlemen, if you have a Geiger counter that is reading, let's use 500 counts per minute. 500 counts per minute, and the area normal is 30 counts per minute. So you're over 10 times your normal dosage. But that's not a normal dosage. Whatever that radiation is extra. It's added. It's not, maybe not normal. That could just be a medical patient. Could be. Well, it could be, and that means something. Medical patients are not supposed to go to the bathroom for some reasons. You can look up. But back to dosimetry. I said that meter's reading 500 counts. Okay, the dose at 30 counts is 0.1 microsievert. Or what? Over 10 times that. So now I'm at, if that dose was 0.1, now it's saying 1 microsievert. And I'm not using great numbers, and I should be, but like I said, I'm asking the question. I need a health physicist to clarify this. Or you could take the ResRad courses and learn how to do it. LNL, I think, ResRad courses offered about twice a year, and that is where health physicists go to catch up, to get a certificate so that they can be certified to go play and testify and witness somewhere else. This is heavy science. I'm 10 minutes in. Most people stopped at 7, so sorry for my poor presentation skills. Anyway, the Geiger counter, whatever dose it's reading, is reading 500 counts. If that was a pure cesium-135 source, what would the dosimetry be? If that count in those 500 counts, if 300 of the 500 were from alpha radiation instead of gamma radiation, so you calibrated, you certified your meter for gamma radiation, but playing around with filters on your meter, you discover that 50% of that reading is alpha radiation. Now, a side note to alpha radiation is because it has no carrying distance, right? We know that it gets absorbed easily in air, mostly because of the humidity and other particles in air absorb alpha energy. They absorb beta energy, but they have very, very little impact on gamma energy. So your meter is reading, for easy numbers, 500 counts per minute. 50% of it's alpha, 50% of it's gamma. Some of it's beta, but you can't discern that because you're lazy, and it takes a lot more with a gamma, with a Geiger-Muller tube detector, to discern alpha from beta from gamma. So I've done videos on this. To put this presentation together is a 4-hour introduction to weeks-long courses offered by nationally funded labs. This is the nuances of nuclear measurements, of subatomic particle measurements. We've stepped beyond electrons and photons and vapor pressures. This is almost the absolutes of energy, and energy pretty well defines what we can touch. Complicated, very complicated. So that dosimetry question again, 500 counts per minute, 50% of them are alpha particles. What would the estimated dosimetry be? The side note on alpha particles, they are localized. They are very close in proximity if they are being read, which means they're very likely airborne or dust resident. And if you breathe, or if you happen to wipe your hand somewhere, you can get skin absorption. Remember absorbing materials through the skin? I carried an arsenic sample that was deadly. It was a calibration sample for an instrument, a lab instrument. That's business. That's how it works. So this is the science of misrepresenting the sciences. It's too long. My coffee got cold. And if only I had a green screen, eh? Challenge is what I'm speaking to has been done. That's why I'm not redoing presentation materials. And you won't get a certificate for listening anyway, other than thank you.